Think about the moment you realize you actually understand something complex. Today, we're cracking the code on system design interviews at FANG companies. Riley, you went from bombing 7 interviews to landing your dream job at Stripe. So what changed, and can you walk us through it?
Sam, I stopped trying to memorize frameworks and started understanding the actual engineering problems. My breakthrough came when I realized system design is just applied constraints optimization.
That's fascinating, Riley. MIT's 2024 study of 3847 system design interviews found that candidates who focused on constraint analysis had 73% higher success rates.
But Jordan, most interview prep completely ignores the constraint optimization aspect. I've analyzed bootcamp curricula. They teach cookie-cutter patterns, not engineering thinking.
Exactly, at my failed Google interview, I drew the perfect Instagram architecture from memory. But when they asked, what if we had 100x more writes than reads, I froze. I hadn't thought about the actual constraints.
That write-heavy scenario completely changes your storage layer decisions. You'd need to consider write amplification and LSM trees, partition strategies for hotkeys.
Hold on, Jordan, you're already diving into implementation details. The real insight is that Riley needed to ask what type of writes. Are they sequential, random, time series data?
Yes, that's exactly what I learned. At Stripe, my interviewer said design a payment processing system, and I immediately asked, what's the geographic distribution, same-day settlement requirements, regulatory constraints?
Wait, regulatory constraints. Most system design prep doesn't cover compliance requirements. But for payments, PCI DSS compliance would fundamentally shape your architecture.
That's the gap between academic system design and real-world engineering. Stripe processes $640 billion annually. They can't just use microservices and hope for the best.
The moment everything clicked was when I stopped thinking, how do I design Instagram? And started thinking, how do I solve the constraint puzzle the interviewer is giving me?
Can you give us a specific example of constraint-driven thinking that changed your approach?
Sure, Amazon asked me to design a chat system. Instead of jumping to use WebSockets and Redis, I asked, are messages ephemeral like Slack or permanent like WhatsApp? Group size limits, end-to-end encryption requirements.
Those questions completely change your system. Ephemeral messages mean you can use event streams and memory caches. Permanent messages need durable storage with efficient retrieval patterns.
And end-to-end encryption adds key management complexity, affects your message routing topology, impacts search functionality.
Exactly, the interviewer's eyes lit up when I said if we need E2E encryption, we can't do server-side search indexing. That's a fundamental product trade-off we need to clarify.
That's systems thinking, not just architecture drawing. You're identifying product engineering tensions that real teams face every day.
But Riley, how do you develop this constraint analysis intuition? It seems like it requires deep domain knowledge across multiple areas.
Actually, Jordan, I disagree. It's pattern recognition, not domain expertise. Every system has the same fundamental tensions: consistency versus availability, latency versus durability, cost versus performance.
Riley's right. I've seen this across 200+ architecture reviews. The best engineers always start with what can we not compromise on? Everything else becomes negotiable.
For payments, you can't compromise on consistency, money can't disappear. For social media feeds, you can't compromise on availability, users expect instant updates. That constraint drives everything.
So you're saying successful system design is about identifying the primary constraint and optimizing everything else around it.
Not just identifying, quantifying. High availability means nothing. 99.99% uptime with 4-second P99 latency gives you concrete design targets.
Yes, at my Netflix interview, they said design a video streaming system. I asked, what's the target startup time? 2 seconds globally or 500 milliseconds in major markets. Completely different CDN strategies.
500 milliseconds globally would require edge computing with video preprocessing, massive bandwidth costs. 2 seconds allows for traditional CDNs with smart prefetching.
And that's real engineering economics. Netflix spends $15 billion annually on content delivery. The latency target directly impacts their infrastructure budget.
The interviewer said, finally, someone who understands that architecture decisions have business implications. I got the offer that afternoon.
This is fascinating. You're describing system design as economic optimization with technical constraints. But how do you prepare for this kind of thinking?
I built a constraint analysis framework. For every major system, search, social, payments, streaming, I mapped the core tensions and typical quantitative requirements.
That's brilliant. Instead of memorizing architectures, you memorized constraint patterns, much more transferable across different problem domains.
Can you give us specific examples? What are the core constraint patterns for different system types?
Search systems, query latency versus index freshness versus storage cost. Social systems, friend graph consistency versus feed generation speed versus privacy controls. Payments, transaction consistency versus processing latency versus fraud detection accuracy.
And each tension has quantitative thresholds where you switch technologies. Search over 100 terabytes needs distributed indices. Social graphs over 1 billion edges need graph databases.
This is much more sophisticated than typical interview prep. You're essentially learning the decision trees that senior architects use in practice.
Exactly, and here's the key insight: most system design problems are just variations of these core patterns. Once you know the patterns, you can handle any variation.
But Riley, there's still the communication challenge. How do you explain these complex trade-offs clearly in a 45-minute interview?
I learned to think out loud in layers. First the business constraint, then the technical implication, then the implementation choice. We need sub-second search, so we need in-memory indices, so we'll use Elasticsearch with enough RAM.
That three-layer thinking makes the logic transparent. The interviewer can follow your reasoning and see how business requirements map to technical decisions.
Let's get practical. What specific mistakes should people avoid based on your experience?
Biggest mistake: jumping to solutions before understanding the problem space. I used to immediately say use microservices without asking about team size, deployment complexity, or operational maturity.
Microservices for a 5-person startup is architectural suicide. You need 20-plus engineers and mature DevOps practices before microservices provide value over well-structured monoliths.
That's a perfect example of context-dependent architecture. The same problem has completely different optimal solutions based on organizational constraints.
Second mistake: not quantifying scale. Saying millions of users is useless. Is it 2 million monthly actives or 200 million? That's a 100x difference in infrastructure requirements.
And different usage patterns matter more than total users. 2 million daily actives in gaming versus social media versus e-commerce have completely different load characteristics.
Gaming has extreme concurrency spikes during events. Social media has time zone-based usage waves. E-commerce has seasonal and promotional traffic patterns.
Third mistake: ignoring failure modes. I used to design happy path architectures. Now I always ask what happens when the primary database fails, when the network partitions, when we deploy bad code.
Failure mode analysis separates senior engineers from junior ones. Anyone can design a system that works when everything goes right. Real systems handle chaos gracefully.
Let's take a quick break. When we come back, specific preparation strategies and resources that actually work. This episode was brought to you by Unstruct AI, creating the most trusted AI news analysis platform, with a focus on the human cost. After all, progress without humanity isn't progress at all. We're back. Riley, you mentioned building a constraint analysis framework. Can you walk us through how someone should actually prepare?
Start with real system case studies. Read Netflix's blog about their CDN architecture, Uber's posts on location services, Stripe's documentation on payment processing. Understand the actual constraints they faced.
Then extract the decision patterns. Netflix chose edge caching because video files are immutable and geographically distributed. Uber chose real-time location updates because ride matching requires sub-second accuracy.
That's much better than generic system design books. You're learning from actual production systems with real constraints and measured outcomes.
Next, practice constraint identification. Take any popular app and ask, what's the primary constraint? For Instagram, it's storage efficiency for billions of photos. For WhatsApp, it's message delivery guarantees across unreliable networks.
And then research how they actually solved it. Instagram uses compression algorithms and tiered storage. WhatsApp uses message queues with exponential backoff and delivery acknowledgements.
This approach builds genuine understanding instead of memorized templates. You understand why certain technologies exist and when to apply them.
For quantitative preparation, I built a cheat sheet of key thresholds. Single machine handles 10K QPS, need load balancing above 50K QPS, need distributed storage above 10 terabytes. Need CDN for global sub-second latency.
Those numbers give you architectural decision points. Below the threshold, simpler solutions work. Above it, you need more complex distributed approaches.
What about practicing the actual interview format? How do you simulate the time pressure and communication challenges?
Mock interviews with experienced engineers but focus on constraint exploration, not solution memorization. Have them change requirements mid-interview to test your adaptability.
And practice explaining your reasoning at different technical levels. Sometimes you're talking to another senior engineer, sometimes to a product manager who joined the interview.
Most importantly, build real systems, deploy a simple app to production, handle real traffic, deal with actual failures. Nothing beats hands-on experience with distributed systems challenges.
That's invaluable advice. Theory only goes so far. You need to feel the pain of debugging a distributed system at 3 a.m. to truly understand the constraints.
Any final insights for engineers preparing for these interviews?
Remember that system design is fundamentally about making informed trade-offs under constraints. Master the constraint patterns, not the solution templates.
And demonstrate business understanding. Show that you grasp how technical decisions impact user experience, operational costs, and product strategy.
Think like an architect, not a coder. You're designing systems that need to evolve, scale, and remain maintainable over years, not just solve today's requirements.
Riley, Jordan, Alex, this has been incredibly practical and insightful. Thank you for breaking down what system design mastery actually looks like.
Thanks for having me, Sam. I hope this helps engineers approach system design with confidence and genuine understanding.
It's been great exploring the intersection of academic research and practical engineering wisdom.
Keep building, keep learning, and remember, great system design is just great engineering thinking applied to scale.
This has been Unstruct AI, where we turn complex problems into clear insights.